In this video, we're going to cover resistance and resistivity. So let's go again and talk about pipe size. How could the wire in a circuit affect the current? If the wire is like a pipe and current is like water that flows through the pipe. If there were pipes with water in them, what could we do to the pipes to change the speed of the water? In other words, change the current. Okay, let's see if you have the right answer. We could change the cross-sectional area of the pipe. Making it bigger will allow more water to flow. We can also change the length of the pipe. Increasing the length will increase the time it takes for the water to get to the end of its trip. Every conductor conducts electric charge to a greater or lesser extent. The last example also applies to conductors like copper wire. Decreasing the length or increasing the cross-sectional area would increase conductivity. Also, the measure of a conductor's resistance to conduct is called its resistivity. Each material has a different resistivity. Resistivity is abbreviated by using the Greek letter rho. Combining what we know about the area, the length, and the resistivity, we can find a conductor's total resistance. So the total resistance is directly proportional to the resistivity and length of the wire and inversely proportional to the cross-sectional area. The resistance R is measured in ohms, cross-section is measured in meters squared, length is measured in meters, the resistivity is measured in ohm meters. What is the resistance of a good conductor? It's actually low. Low resistance means that electric charges are free to move in a conductor. Go ahead and click on the link that I provided in Edmodo. This one should be called Resistance in a Wire, and go ahead and play around with this a little bit. As you can see, you can move this up and down and see what happens. And check out this. And there you go. Okay, so here are some resistivities of common conductors. Notice that these are all times 10 to the minus 8 ohm meters. Here we have copper at 1.68, gold, aluminum. Here we have iron at 9.7, platinum at 10.6, mercury 98, nichrome is 100. Rank the following materials in order of best conductor to worst conductor. You can go ahead and use the chart that's provided. Pause the video now. Okay, so let's see if you have the correct order. You should have chosen C, copper first, then iron, then platinum. What is the resistance of a 2-meter long copper wire whose cross-sectional area is 0.2 millimeters squared? Now, this is a trick question because notice you have to have the cross-sectional area in meters squared, not millimeters squared. Now, here's the tricky part. You have to actually convert the meters one time and then meters again 2 times because it's squared. Go ahead and pause the video now and solve this problem. Okay, so let's take a look at your answer. The resistivity actually is 1.68 times 10 to the minus 8. Because it's copper, you need to look that up on the table. The length is 2 meters, and we needed to convert the 0.2 millimeters squared. It ends up being 0.2 times 10 to the minus 6 meters squared. When you take the numerator and divide by the denominator, you end up with 0.168 ohms as your answer. The following resistors are made of the same material. Rank them from greatest resistance to least resistance. Go ahead and pause the video now. Okay, you didn't need to look at the answer choices because I wanted you to go ahead. I mean, you could have called this 1, 2, 3, 4. If you put them in order, let's see if you had the right order. You should have had the same order as B. So you should have said RZ is greater than RY, which is greater than RX, which is greater than RW. Okay, you could have also said RW is less than RX, which is less than RY, which is less than RZ. It doesn't matter which way you put it. What diameter of 100-meter long copper wire would have a resistance of 0.10 ohms? Go ahead and pause the video. Okay, so let's take a look. First thing we need to do is we need to have the cross-sectional area, and we're going to find that through the equation R equals rho L over A. We know that the cross-sectional area is equal to pi r squared. We also know that r, the radius, is equal to the diameter divided by 2. So we're going to have to substitute this in order to get the area in terms of the diameter, because that's what we're looking for, is the diameter. Okay, if we substitute this in for A right here, we end up with 4 rho L over pi d squared. Okay, solve for D, ignoring this piece right here. Okay, so they left it in, but you don't need to. So there we go. And D is equal to the square root of 4 rho L over pi r. In fact, this would be wrong if they left this piece in here. Okay, solving for D, substituting in our numbers, we end up with 4.625 times 10 to the minus 3 meters, or 4.6 millimeters. You could even say 5 millimeters. The length of a copper wire is cut in half. By what factor does the resistance change? If you need to, pause the video now. Okay, so let's take a look. Hopefully you chose 1/2. The length is directly proportional to the resistance. The radius of a copper wire is doubled. By what factor does the resistivity change? Go ahead and pause the video if you need to. Okay, so let's see if you chose the correct answer. Hopefully you chose 1. In the next video, we're going to talk about circuit diagrams.